Hello, everybody, and welcome to this week's lecture. This week we're going to be talking about Chapter 3 in the course textbook. Your reading is going to be obviously Chapter 3, and that is from pages 41 to 50 in the textbook, so quite a bit shorter than last week, and hopefully we can get through this a little bit quicker. It's a pretty short chapter. So this chapter is called Designing for Human Health and Safety. So as an introduction, protecting the health, safety, and welfare of building inhabitants is a core aspect of interior designer's job. That is something that you've probably heard in a lot of your other classes up until this point. It's just a very common point that is brought up a lot because that is our main focus as interior designers. We're designing a space and obviously we want it to look aesthetically pleasing and interesting, but at the same time we also have to consider who we're designing it for, and that is the building inhabitants, and we have to take their health, safety, and welfare into consideration in order to ensure that our design is going to support those things. So going on here, every decision an interior designer makes affects the health, safety, and welfare of the public in some way. Interior designers must be familiar with and follow building code requirements to ensure the health, safety, and welfare of building occupants. And failure to follow these requirements could result in a designer being held liable should an incident occur. So you guys have already taken your building codes and standards course. So a lot of this chapter will be review from that. You should be pretty familiar with some of these topics at this point. But basically, building codes are what define, or they govern how we design our buildings, with the goal of supporting the health, safety, and welfare of the occupants of the building. All right, so codes are what we look to ensure that we are conforming to particular standards, and they just help us ensure that the building is going to be safe. All right, and if we don't follow building codes and we pick and choose what we decide to follow and just do whatever we want, obviously that's a bad thing, because something bad could happen, and ultimately if you're in charge of that and you make that call, you could end up being held liable for it, and it could get really ugly. So we need to make sure that we follow building codes. Obviously they're a good thing. All right, so going on, the next part of this chapter that we're going to be discussing focuses on the human body a little bit. A lot of it's pretty self-explanatory. It's probably stuff that you already know, or it's maybe a review from science classes that you've had in the past. So I'm going to try to breeze through this as much as I can, but you should get the gist of it as I'm talking about. I won't really need to go into much detail on it. All right, so basically when we're designing buildings, we want to design them in a way that maintains thermal equilibrium. All right, so thermal comfort within a building is influenced by several different factors. For example, it's influenced by air temperature, air humidity, and air movement. The amount of clothing a person is wearing is going to affect your thermal comfort, and also the amount of heat that's being emitted from objects that are within the interior space. Those are all going to contribute to how comfortable you feel inside of an interior environment. A perception of thermal comfort can vary between individuals. So, for example, one person might think a space feels really cold, another person might think it feels just right. That's something that I always ran into when I was working full-time in an office. Was every day I go in, I always had to wear like an extra layer because I always felt super cold inside of that space. And even when I was in the CAED building at Kent, I remember that being very cold too. I always felt like I had to wear a hoodie or something when I wanted to work in there. Um, I'm just a cold person in general. I always feel cold and I need to have like a little space heater going. But then there's a lot of other people who think that feels just right. One of my good friends used to live with somebody and he always would keep his apartment at 62 degrees, which is just insane. But to him, that was the perfect temperature. That's where he felt comfortable. So temperature, thermal comfort can be kind of a subjective thing, but our main goal as an interior designer, working with architects and engineers, we want to design buildings and interior spaces in a way that satisfies the majority of people. Okay, so there's kind of like a perceived level of comfort that most people think is adequate, and that's kind of what we are aiming for. We're not going to always satisfy everybody. There's always going to be people who need to wear a hoodie maybe inside, or wear less layers of clothing to feel comfortable, but our goal is to satisfy the majority of people who will be inhabiting interior spaces, right? And that should be obvious. Human body heat production, all right? So thermal equilibrium, that refers to the set of conditions that allow your body to stay at a normal body temperature with the minimal amount of body regulation, okay? So we're trying to design spaces to where the human body has to do as little work as possible to maintain a thermal equilibrium. All right, so thermal comfort basically. Going on, thermal comfort, so that is the feeling that's achieved when heat production is equal to heat loss. Clothing and acclimation, as time has progressed, buildings have been designed to do more work to ensure thermal equilibrium is achieved. All right, so these advanced systems basically that we're building into modern buildings, they allow our bodies to do less work to be comfortable. We also do not have to rely as much on layers of clothing for work. All right, so like I was saying before, you don't have to always put on a hoodie or something like that to feel comfortable, because building systems, they have all these temperature sensors and things like that built into them nowadays that are keeping track of the interior temperature, and they're doing whatever they can to regulate that to be consistent so that you're always going to feel comfortable. All right. However, more advanced thermal control systems that we have nowadays, those are going to lead to greater energy usage. All right, so you always have to have a balance. You want the building to make you feel as comfortable as possible, but not to the point where it's going to have a negative impact maybe on energy usage, so like your heating bills, and also maybe impact on the environment. There's always has to be some sort of a balance there. You can't really have it totally one way all the time. All right, so moving on, visual and acoustic comfort. Visual comfort is a broad term that covers several factors and situations. Visual comfort is influenced by things such as the amount of natural and artificial light inside of a space, and the interaction between light and the materials that are within a space. All right, so for example, some situations where visual comfort would be poor, maybe if you're like at a movie theater and let's say they didn't turn off the lights in the movie theater and you're trying to watch the entire movie with the lights at full blast. All right. Or like if you're in a classroom, and this always used to irritate me, in high school or even in college, when you'd be trying to watch a lecture on the screen and the instructor leaves the lights on. Like, it's much easier to see what's going on a bright screen if you have the lights dimmed down, okay? So that would be an example of like a poor visual comfort, right? You want whatever you're looking at to be easy on your eyes and it not be straining. Also, maybe sunlight reflecting off of a reflective surface producing a glare. So let's say you're in an interior space and you have like a really reflective, maybe like a concrete flooring. Let's say you're in the CAED building, for example. So they have that polished concrete floor in there. And let's say maybe in the evening you get sunlight that's coming in through those windows and it's going to be bouncing off of that floor. And if you're in the right spot, well, actually maybe the wrong spot at the wrong time, that light is going to bounce off of the floor and hit you in the eye, all right, as a glare. So that has to be something that we have to consider as well. What materials are we using, and how is sort of the lighting situation going to, interact with those surfaces? We don't want it to be interacting with them in a negative way that is going to cause a discomfort to the inhabitants of the space, right? So we have to think about that. The main point that I'm trying to say here is interior designers must consider visual comfort when they design a space. Striving for good visual comfort is going to influence the selection of elements like lighting fixtures, wall colors, and flooring. All right, so this image here, this is a space within the Vocon Cleveland office. For those of you who don't know, Vocon is where I used to work full time. I still work with them on occasion, in a sort of contracting role. But when I was there in the office full time, this is one of the spaces that they had recently completed. So they did a whole office renovation, and this is one of their meeting rooms on the first floor. All right, so they called it the Red Room, and the whole point was they wanted something that reflected the brand colors, and they wanted to be really bold and really cool looking and stuff like that. But obviously red is a very intense color, and if you're using on every single surface, so they have it on the walls, they have it on the floor, the furniture, and the ceiling here, you need some way to sort of counteract that harsh, intense color to bring it down to a level that is reasonable, so you're not discomfortable when you're sitting there inside the room. All right. So for example, something that they did to make this room inhabitable and not a pain to be in is they added in like this indirect lighting. So back here you can see there's sort of this area of the ceiling that goes up higher behind, and they have these indirect spotlights that are coming down, and that indirect is kind of filling the room with an overall illumination. And then directly above the table here, they have a fixture that is basically just bringing in diffuse lighting into the space. So it's indirect. It's not just casting like a beam, like a harsh beam of light in the space. Overall, you can see the lighting is pretty dim. They keep the lighting levels down low so that it's more comfortable in your eyes. There were times where I go into this room, and if you have the lighting on like full blast, like it really is, it just kind of hurts your eyes. So that's kind of a strategy they used, is using this type of lighting that's indirect and also keeping it dim so that you still have a visual comfort, even though you're using materials and colors that are kind of intense. All right, so there are ways to, whatever you're designing, there's always a way to make it comfortable for the inhabitant. All right, so a tip from the book here for achieving good visual comfort: you want to avoid creating strong contrasts that may make vision difficult or painful. For example, don't put a really bright object against a really dark one, and vice versa. So don't put a really dark object in front of something that's really bright. All right. Interior designers must also be conscious of acoustic levels within a building to ensure comfortable noise levels within an interior space. All right, so this is something we're going to get in deeper later on in the course when we actually talk about acoustics specifically. But there's just a few basic things I want to touch on here. So for example, soft materials and surfaces are going to absorb noise and dampen sound levels. So like if you're in a gym, for an example, well, actually, let me read this one first. Hard materials and surfaces will allow sound waves to bounce through a space easier and will cause acoustical discomfort. So like I was saying, if you're like in a gymnasium, usually they have like acoustic panels attached to the walls to dampen the sound because you have a lot of hard surfaces in that environment. So like you have the hardwood floors, the walls may be like CMU, so they might just be like painted concrete block or something like that. You have the bleachers, all this stuff with hard surfaces is causing any sound wave inside of that space to just bounce around, and you get a lot of reverberation and like echo, and it's usually really loud in there, and it's hard to hear what people are saying. So to combat that, you have to incorporate some soft materials. So like I said, they'll put acoustic panels maybe on the ceilings or on the walls to do that. Also, in corporate buildings, those usually have a lot of hard surfaces as well, glass walls, and then like drywall. Just a lot of things that allow the space or allow sound waves to bounce around, and it can make it hard to hear. So in those situations, you want to use a lot of like upholstered seating or carpet as much as you can to kind of absorb as much as that sound as possible. All right, so moving on, other human environmental requirements. Building systems must also meet human needs for water and waste removal. They must also provide fresh air and protect us from bodily harm. Water and waste removal. Plumbing systems allow for the removal of waste and provide us with fresh, clean drinking water for sanitation purposes. Fresh air. Building ventilation systems ensure the air we breathe indoors is fresh and clean. Here's a little video I included here about understanding indoor air quality. They just kind of talk about specific considerations nowadays for designing spaces. What you need to think about in terms of the quality of air inside of a building and what can contribute to the air quality not being so good. All right, so that's a pretty interesting video. Protection. So appropriately designed buildings are safe and they provide spaces and systems that facilitate proper sanitation. So, for example, smooth flooring surfaces can prevent trips and injuries from falling. Sturdy handrails protect us from falling when we're moving vertically through a building, on a set of stairs or something. And then smooth surfaces can be easily sanitized. So you also have to consider all those things in terms of safety. Are you providing them with the proper, means of moving through the building and being safe in terms of like handrails and stuff like that? Are you minimizing the amount of transitions between flooring materials to reduce the amount of tripping that could be taking place? Are the surfaces that you are putting into the building, can those be easily cleaned with just like a commercial cleaner? Are the materials durable enough to hold up to commercial cleaners? So all those types of things have to be thought about as well. There's a lot of layers that go into designing a space properly. Poorly designed buildings can be breeding grounds for microorganisms that can cause illness. All right, so if a space cannot be properly sanitized, if you use a lot of materials that are like hard to clean and they don't get sanitized regularly, that can lead to an environment that is not really healthy to be in, because that is just allowing these microorganisms and bacteria to grow. All right, so then you breathe them in, and that leads to like respiratory problems. So there's all kinds of stuff that you have to be considering in terms of like air quality and materiality. Designers also need to pay attention to aspects of a design that could cause harm from falling objects, explosions, poisons, corrosive chemicals, harmful radiation, or electric shocks. So that's from the textbook. That's true, but that's not going to be something that you're thinking about probably like on a regular basis. That's probably going to be more in the hands of like architects and engineers, but you should be familiar with those things as well, so that you can kind of communicate through those design issues with the architects and engineers. Proper designs help prevent and suppress fires, and they facilitate escape from burning buildings. All right, so we also have to think about fire protection. Do we have a proper means of egress from the building? All of that. And that should be kind of stuff that you've talked about in your codes course as well. Hazardous materials. All right, so many interior designers do renovation work on old buildings, and these old buildings contain hazardous materials. Therefore, it is important for interior designers to be familiar with these materials to avoid dangerous levels of exposure. All right, so during the demolition phase of a project, hazardous materials can be uncovered that need to be dealt with. So some examples of these: mold, lead paint, asbestos, vermiculite insulation. All right, now we're going to talk about some of these sort of in depth. All right, so first we have lead. So lead is a neurotoxin that can accumulate in the body. It's mostly harmful to babies and young children, as exposure to it can lead to developmental issues and even death in some cases. And lead is most commonly found in the form of lead paint. All right, so 3/4 of the houses in the United States built prior to 1975 contain some level of lead paint. It was also included within pipes and soldering until 1985. And to get rid of it, it requires a special abatement process to remove properly. So a little story, like I've said in the past, I live in a really old house. It's over 100 years old, and our house has lead paint. All right, so when we bought it, the exterior of the house, so it's kind of split into two halves. And I think I've showed you a picture of it before in like the previous course. But the bottom half, when we bought it, was covered in like a vinyl siding, and the top half of it is a cedar shake, for those of you who know what that is. But we decided that we wanted to remove the vinyl siding on the bottom, because what they did is they just put that vinyl siding over top of wood siding, the original wood siding on the house, and we were like wanting to restore that wood siding. So we pulled off all the old vinyl siding, and then when we got to the wood siding underneath, it was painted white with, old lead paint. It was the original paint that was on the house. And it was in really bad shape. I mean, the wood was in good shape, but the paint, what lead paint does, if I go here to this next slide here, basically this is what it looked like. So as it gets old, it does this it gets this cracks in it and kind of like a spider web pattern sometimes, and it just looks really bad and it chips off. So in order to refinish the wood like we wanted to put a stain on it, an exterior stain instead of an exterior paint. We had to remove all this old paint, all right, and that's a huge process. And normally, the correct way to do it is to hire a specialized abatement team, and they're going to come in and they're going to basically go into hazmat suits and wear these huge respirators and use a HEPA vacuum, all this complicated stuff, because whenever lead particles get into the air, that's when they become dangerous because you actually breathe them in. All right, so you don't really want to sand this or do anything that's going to like turn into particles that you can breathe in. So what we ended up doing actually is we probably didn't go the best route in terms of doing this, but like we couldn't really afford to get the proper abatement. So what we ended up doing was we took like heat guns and we actually went around and we heated up the paint, and then we just used scrapers and we scraped all the lead paint off the exterior of the house. And we had special masks, so we bought lead rated respirators that we wore the whole time we did this, so that we didn't like breathe in any of those fumes, because as the paint heats up it creates like fumes and stuff. So we basically went around the entire exterior of our house. It took us like, I don't know, an entire summer to do, but we scraped off all the old paint, and then once we got all the old paint off, we had to like do a light sanding on the wood, and then we were able to get it refinished. But the professional process of removing lead paint is actually like really intense. This is a video that shows that. All right, so that's actually really interesting. You guys should watch this to kind of get how they do that. But they'll come in and they have a whole. It's crazy. Just watch the video. But lead is pretty serious. They don't use it anymore. Obviously, it was kind of banned after the 1970s. But if you're in an old house, you can guarantee that there's probably going to be lead paint in it somewhere, and you just have to be careful of it. All right, if you're going to mess with it, you just have to make sure that you do it in the right way that's going to keep you safe. All right, so going on, asbestos. So this is a material that's found in a lot of old buildings that were built before the end of the 1970s. It was a common ingredient in floor and ceiling materials. So for example, a lot of ceilings in some of these old buildings are like an acoustic tile, and those will have asbestos particles inside of them. Or some of the old vinyl floorings that they have in these older buildings, the adhesive that they use to hold those down to the floor, those contain asbestos. And it was also a common insulating material for like ductwork in old houses and stuff. It has a whitish gray or light brown color, and it looks like coarse fabric or paper. So asbestos is only really dangerous when it gets into the air and you can breathe it in. Okay, so very similar to lead, but it's probably more dangerous than lead, I would say, because it can lead to cancer. That's like its main thing, is if you're exposed to it too much, you can get cancer from it. And if you remove it improperly, it can actually be more dangerous than just leaving it alone. So if you're not touching it, like I said, it's not really that big of a deal. But if you go to remove it and you do it the wrong way, you can actually kick those asbestos particles into the air, and that's when it becomes dangerous. So you'd probably be better off, if you don't have a professional removing it, just to leave it where it is. Another example from my house. This is not a picture of my house, but we had something very similar. So you can see this is like a duct inside of a basement or something. And this like white paper around the duct is actually asbestos. So inside of all of our walls at our house, we had the same thing where we'd have these old ducts and they were all coated in an asbestos like coating. And it was fine just to leave it. Like we wouldn't have had to replace it all, but we were getting our entire HVAC system replaced when we moved in. So the heating and cooling contractor, they suggested that we actually go and remove all the old ductwork from the house and replace with brand new. So that's what they did. They were able to go in and remove all of that old asbestos, and now we just have regular modern ductwork in our house. But that's another common thing that you're going to run into. And if you're if you went to school in like a really old high school, for example, like I did, there's usually a lot of asbestos present in those buildings. So whenever they go, like my old high school, they demoed it and they built a brand new one. But whenever they demoed it, they had to go through all these procedures to remove the asbestos safely so that nobody breathed in and got negative health effects from it. But here's a video showing how they actually go in and remove asbestos. It's pretty similar to the lead one, but it's pretty interesting. Next, mold. So this is something we are all probably pretty familiar with. So mold is caused by dampness inside of buildings, and it dampness is what supports the growth of bacteria, which causes mold. All right, so mold may need to be removed by a professional depending on the level of severity. Here's a video of mold removal, so you can see how that works. But here's an example of what I mean when I'm talking about mold. So here you can see some water damage got in, and it has been sitting against the wood and the face of this wall, and that dampness causes this black mold to grow. And it's a problem because these spores, when you breathe them in, it causes respiratory issues. So definitely something you want to avoid and get taken care of if it's present. All right, so now we're going to talk a little bit about building codes and standards. I'm just going to try to get through this pretty quickly because all of this stuff in this section should be a review from your last class. All right, so we're not going to go too in-depth or anything like that because you should already be familiar with all these things, but we're just going to touch on them. So building codes are regulated set of standards that govern the way architects, engineers, and interior designers design buildings. They provide the minimum requirements necessary for a building to support the health, safety, and welfare of building inhabitants. All right, minimum is kind of a key word here. That's your baseline that you need to meet to ensure that the building is safe, basically. All right, it's just telling you the very bare minimum. Obviously, you can shoot a little bit higher, and a lot of buildings do. They actually go above the minimum. There are two types of building codes. Okay, so there are prescriptive codes and performance codes. Prescriptive codes mandate the way a process is to be carried out by defining means and methods. All right. So, for example, how are we constructing something? That'd be an example of prescriptive code. What's the process of putting together this wall assembly, for example? Think of something like that. Performance code, these state the objectives that need to be met, and it may offer options for compliance. So performance codes, these are more things think about building occupancy levels, like you probably learned about in the last course. What is the required occupancy for the amount of, or the type of space that you're dealing with? How many people can be in that space at one time? All right, so building code requirements are going to vary depending on jurisdictions. All right, so a jurisdiction just refers to a geographical area. So code requirements from one jurisdiction might differ from another jurisdiction. So code requirements in New York City are going to be different than those in Los Angeles, for example, because there are a lot of different, obviously, climate, all kinds of different requirements based on just the area. Building and health departments are examples of governing bodies that enforce code requirements within jurisdictions. All right, so the Kent Building Department, if we're in the city of Kent, they're going to be the ones who enforce all the code requirements for new construction projects in the building of Kent. All right. Jurisdictions usually have strict requirements about who can design a project and what drawings are required for a project. All right, so drawings must usually be stamped by an architect or engineer who is licensed to practice within the state. Sometimes interior designers are allowed to oversee, they're not allowed to oversee projects, and they must work as a part of an architect's team. All right, that's how it is a lot of the time. Um, it kind of depends on the state though, but usually as an interior designer, you're going to be working under an architect, and whenever a project is completed or you get done with a set of drawings, you have to give it to the architect who then has to approve them, and that architect has to be licensed to practice in that particular state where the project is taking place. And if he is and he approves them, he can put his little seal on them and stamp the drawing, and then they will go on to the building department, and the building department will review them and make sure they're in compliance basically with the codes. Some states allow licensed interior designers to stamp their own drawings, but this is depending on the type of project. Okay, so for example, the building needs to have like a limited number of stories and square footage. Interior designers often work closely with architects and engineers to ensure the proper code requirements are being met. All right. The ICC International Performance Code for Buildings, that is a model code that was developed to unify code requirements across geographical areas. So you can think of this when we're talking about the ICC. That's basically just an overarching code. It's kind of like a blanket code for like, let's say the entire United States or multiple countries. Okay, so it's just a set of standards, and then basically what different areas do is they will take that standard and they will adopt it. They'll either adopt exactly what's in there, or they will take it and they will modify it in some way that better suits their needs for their particular region. All right, so the ICC, that was introduced by the International Code Council in 2002, and it's been adopted statewide in some or all. Let me start that again. It's been adopted statewide or in some localities in all U.S. states. So in some form, it's going to be present in every state in the country. All right. Building codes for a particular area, like I said, they're based on international codes, but they may be modified by that local jurisdiction to better suit their area. All right, so those are often referred to as local codes. Not all jurisdictions update their codes on a regular basis. The most recently adopted codes for a particular area may not be based on the most up-to-date standard. All right, so for example, maybe your area, maybe they used codes from like 2012, for example. They may choose like a set interval, let's say like every few years, like every 3 years or every 5 years or something, they're going to update their codes that they have to the most current standard. So they're not always going to be like totally up to date. So there might be like an ICC code and it's like, the 2020 standard or whatever, but your local codes might refer to the ICC from like several years ago. All right, so they're going to adopt those sort of like in waves or intervals of several years usually. And plans examiners, fire marshals, and building inspectors, those are all the people who examine a building's design to ensure that proper code requirements are met. All right, so those are the people who like enforce the code requirements. Standards and organizations. So standards defined in building codes are always developed by several government agencies. There's a whole bunch of them that I'm sure you have already talked about in your codes course. So I'm not going to go into too much detail. I'm just going to list them out here and just mention them. But these are the examples. The NFPA, so National Fire Protection Agency, the National Standards Institute, ANSI, American Society for Testing and Materials, ASTM International, American Society of Heating, Refrigeration, and Air Conditioning Engineers, Underwriters Laboratories, UL. Occupational Safety and Health Administration, OSHA. All right, and then we have the Americans with Disabilities Act. So you've probably already talked about this as well, but just as a brief review, ADA is basically a set of accessibility guidelines that was a part of a larger legislation that was passed in, I believe, 1990. So basically what these do is they provide a set of accessibility standards for building design. How do handicapped people basically get in and out of a building, and how do they move throughout the space in a way that is well suited to them? They need to be able to access all the same things as somebody who is not handicapped, for example. So when we design, we have to think of them and follow this set of standards to ensure that they're getting the same treatment as everybody else. All right. So basically, within the ADA, there's a section called Title III, and the Title III is what sort of defines the standards for architects and designers to follow for buildings. And these were incorporated into the 2010 ADA Standards for Accessible Design. So this is sort of the document that we as interior designers are going to be referring to whenever we're designing for accessibility needs. The ADA requirements deal with architectural concerns such as accessible routes into, out of, and within buildings. The impacts of ADA are commonly seen in the design of commercial restrooms, which must provide ample space for wheelchair access. All right, so just think about like if you're in a commercial space and there's a set of, you go to the restroom and there's a set of stalls there. There's going to be like a handicap stall, and that handicap stall, the standards for the way it is laid out are going to be defined within this document. All right. You're going to have all your clearances, all of your dimensions that you have to follow to ensure that somebody who's in a wheelchair can get in there, do their business, and get out in a way that, works fine for them. All buildings with public accommodations and or commercial facilities must conform to specific ADA requirements. ADA requirements are not as clear for renovation projects. During renovation, specific areas may need to be altered to meet ADA standards. All right, and then lastly, energy efficiency requirements. So energy efficiency requirements mandate a minimum applicable level of building performance. Energy efficiency requirements are defined in the International Energy Conservation Code, all right, the IECC. This code addresses energy efficiency, including cost savings, reduced energy usage, conservation of natural resources, and the impact of energy usage on the environment. Many states also have their own energy codes, just like I mentioned with just the regular building codes. It's going to vary depending on like jurisdiction, exactly what has been adopted. And the most generally used standard for commercial buildings in the United States is this one right here. It's got a really long name. Basically, it's just energy standards for buildings, except low-rise residential buildings. So that encompasses most commercial buildings. And then the one for residential buildings, that is this one here, 90.2. Energy efficient design of low-rise buildings. All right, and then in 2012, the International Residential Code incorporated residential provisions from the IECC into its own sections on energy efficiency. So if you're working with the IRC, they're going to have their own stuff in there about energy efficiency that's been pulled from the IECC. All right, so that's going to do it for this lecture. If you have any questions about anything that we covered here, go ahead and just email me or text me and I will get back to you.